Sue bought $24.55. Some were 15-cent stamps and the rest were 25-cent stamps. How many of each did you buy? So that is our given information. Our unknown information, right? The question says, how many of each did she buy? So there's two different unknowns, right? This is continuing to work with systems, so we should be working with two variables. So we can say X is equal to the number of 15-cent stamps, whereas Y is equal to the number of 25-cent stamps. For the equation, we know the total value. So we can say total cost of stamps is equal to the cost of 15-cent stamps plus cost of 25-cent stamps. In our substitution stage, our total cost was $4.55. That is equal to the cost of 15-cent stamps. Well, we would multiply 15 cents by the number of 15-cent stamps that we bought, which was X. So that will be 0.15 multiplied by the number, which we don't know. And to that, we're going to add the cost of 25-cent stamps. So that's going to be 25 cents for every one of the stamps that we bought. So those are the Y stamps. So you might not see the second equation for the system yet, but remember, the problem said have 25 stamps. So if we highlight that part and realize, okay, that's a second equation. For X added to Y, right, that has to equal a total of 25 stamps. So that gives us our second equation. So strategically, right, if you wanted to, it would be very easy to solve this by substitution because we already have ones here. So it'd be very easy to get X or Y by itself. You could also very easily use a multiplier. Remember, if you want to get rid of decimals, in this case, you could multiply everything by 100. So please solve this example on your own to continue. Example 2 goes on to the next slide. So if you go to the next slide, in this video, you'll be able to see example 2. For this problem, it's important to note that interest earned is equal to the principal times the rate times the time at which you invest it. Now, the tricky part of this problem is that $8,000 is split up in between the two bonds. So for our given information, we have this. Our unknown information is how much we're investing in each. So X could be invested in bonds and let Y equal what's invested in stocks. So for our equation, for our system, we're going to have two equations. The first one, we know that the amount invested in bonds added to the amount invested in stocks has to be that total amount invested, $1,000. All right, we know that. It has to add up to a total of 8,000. Now, in total, this person wants to earn an interest amount of $930. So for our second equation, our interest, right, has to equal $930. So we're going to write for our second equation, the interest equals our principal times our rate times our time. But we have two different principal amounts in this particular problem. So we would say principal 1, rate 1, principal 2, and rate 2. Right? They're both going to be invested in the same amount of time because it says we want to get an annual earnings of $930. So the time is going to be 1 year. So to get that second equation that we're looking for, because right now we only have one, right? Our first equation is right here. Use a highlighter. That's our first equation. Our second equation is coming from the interest formula. So we're going to do some substitution to get through that part. So for substitution, our interest has to be $930 in total. Okay, so our principal 1, let's say that's how much we're investing in stocks, has to be multiplied by our rate, which is for our bonds rate, that would be 6%. So we're going to write that as 0.06. To that, we need to add the amount of money that we're going to get back from investing in stocks. So that's going to be the amount that we invest in stocks, which we don't know, multiplied by 15%. So the amount from each of those should add up to a total of 930. So that gives us our second equation. So now we have a system, right? And just like example 1, right, substitution will be pretty easy, right? Because you can solve the first equation for x or y very easily, substituting in that into the other equation and then solving for x, and then plugging whatever you find for x in, and then figuring out what y is. So this is the setup for example 2. Now for this last one, I just want to give you sort of a jumping off point. It says, if you wanted to graph all pairs of numbers whose sum is greater than 10, right, what would the graph look like? So it might help to start by thinking of numbers that add to something that's close to 10, and then think of other numbers that would add to something that's greater than 10. Hopefully you'll understand that the list is infinite, right? Because 2 plus 11 is over 10, right? 2 plus 12, 2 plus 9, right? There's a lot of different combinations. So how you would graph that is to set up a coordinate plane and think about, okay, where on my coordinate plane would be sets of coordinates that when they are added together, they would have a sum that's greater than 10. So just think about that.